Okay, good morning, afternoon, or evening, everybody. Welcome to the Pieces of SWOTs, Learn How to Subset Ozone Monitoring Instrument, or OMI data, with the Goddard Earth Science Data and Information Services, or GES DISC, Level 2 Data Subsetter webinar. This is your host, Jennifer Brennan. While everybody's logging in here, you may have noticed we have two optional polls. You'll find those located at the bottom left and middle portion of your page. And we certainly do appreciate your feedback on these polls. I have 2 p.m. Eastern Daylight Savings Time, so we are going to go ahead and get started. What I'd like to do first is to go over a few logistics related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod, and you'll find that located on the lower right-hand corner of your screen. This works like a chat. Today's webinar is being recorded. The recording will be posted both to our online Adobe Connect webinar catalog as well as to our NASA Earth Data YouTube channel within a few days of completion. And what I'll do is I'll send an email to all of the registrants that include the direct link as well as the YouTube link to today's webinar. In addition, today's presentation files will also be available for download at the end of the webinar. As far as timing is concerned, today's webinar will be 1 hour long. We've allocated 45 minutes to the presentation with an additional 15 minutes for the question and answer period. So once our speaker has finished his presentation, what we'll do then is we'll transition to an optional set of final polling questions. And then from there, we'll jump directly to the Q&A period. And then just one final note, depending upon the volume of questions that are received, what we'll do is we'll extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who may wish to stay on the line. What I'll do next is I'll pull up today's agenda. All right, while that's loading up here. All right, during the first few minutes, our speaker will provide an overview of the Ozone Monitoring Instrument, or OMI, Level 2 data, and the Level 2 subsetting process. From there, we will transition to a use case example and a step-by-step tutorial on how to use the Level 2 subsetter. And then the final 10 minutes or so will be spent on a second use case and a wrap-up with some notes and additional resources. With that, it is my pleasure to introduce today's speaker, Dr. James Acker, who is a Senior Support Scientist at the GES DISC. Jim?
Hello. And I'd like to welcome everybody to the webinar we've entitled Pieces of SWOTs, and it's about the GES DISC Level 2 Data Subsetter. And as Jennifer told you, I'm James Acker, and I am a Senior Scientist at the NASA Goddard Earth Sciences Data and Information Services Center, which is the GES DISC, as you'll probably see more during the presentation. My presentation today is on the Level 2 Data Subsetter, which is a new capability that makes it easier to work with some of the data that's in our archive. And the Level 2 Data Subsetter was created due to an increased demand from the scientific community for streamlined and tailored data access. Now, there are some services that currently exist for the extraction of Level 2 data, but they tend to be highly specified for specific products, or they do not provide a full level of Level 2 data subsetting support. So this initial release of the Level 2 subsetter is available for most of the Level 2 data products from the Ozone Monitoring Instrument, also called OMI, which is flown on board the AURA satellite, which launched in 2004. And the initial release of the subsetter provides these following capabilities. It allows the selection of specific variables within a data file. It allows the user to specify a latitude-longitude box. It allows the subsetted variables to be output as cropped files for this specified region. The index variables are generated for each of the subset dimensions. It does provide for dimensional subsetting, which I'll talk about a little bit later. And it also, very importantly, preserves the original file structure, the metadata, all the dimensions, the data types, and the data attributes. And that's a lot, but there is a lot in these files. Okay, now before I get to the Level 2 data subsetter, I want to give you some information about the AURA satellite and OMI. Now, AURA was launched on July 15th, 2004, at night, as you can see in this picture. It was a very dramatic launch. And it carried 4 instruments that were all designed for observations of the atmosphere. And in the schematic diagram, you can see where the 4 instruments are on the satellite. And one of them was called the High Resolution Dynamics Limb Sounder, or HRDLS. Another one was the Microwave Limb Sounder, which is MLS. OMI was the 3rd instrument, and the Tropospheric Emission Spectrometer, which was just decommissioned in January, was the 4th instrument. Now, on this slide, you can see a picture of what the OMI instrument looked like in the laboratory before it was launched. And here is a schematic diagram of how it works. And it's very important to note in this slide what it does is it scans the Earth's surface. It's actually scanning the atmosphere above the Earth's surface, but it creates a ground tract that looks like a swath, as we call it. And you can see this swath is up to, I'm not sure, it's a very, very wide swath. And the resolution you can get is about 13 by 24 square kilometers. And as you'll see in a subsequent slide, as AURA orbits the Earth, OMI can provide nearly global coverage in a single day. And it provides concentration information for ozone, which is part of its name, and nitrogen dioxide, sulfur dioxide, and a couple other ones that I'm not going to give you the names of right now. Now, OMI was built by the Royal Netherlands Meteorological Institute, and the initials of the Royal Netherlands Meteorological Institute in Dutch are KNMI, and I will not try to mispronounce the name as shown here. And this is a very detailed schematic of how OMI works. And it's a complex instrument, and it provides really good data. So that's why we use OMI. It's a follow-on instrument for TOMS and the EP TOMS, the Earth probe TOMS, and can do quite a bit, as you'll see. So the subject of this webinar is the need. Why do we need Level 2 data subsetting? And what are the basic functions of the Level 2 data subsetter? And I will then give a step-by-step explanation of the Level 2 subsetting process. So, first of all, here is an example of Level 2 data. And as I said, it gives almost global coverage. There's a little bit of space between the scanning swaths, but this is the data, the UV aerosol index data for a single day in August. Okay, so Level 2 data consists of data products that are in the basic same form that they were acquired by the satellite instrument. And so, as I've said before, for many of these instruments, the data is what's called an orbital swath. And it's the data acquired as the satellite orbits and the instrument scans the Earth. Okay. Now, one thing to point out is Level 2 means that the contents of the file are derived geophysical variables. The actual data collected by the instrument is either called Level 0 or Level 1. Okay, and this data is then processed to provide the Level 2 variables. And breaking it down, this gives you an idea of what a single Level 2 data swath looks like on the surface of the Earth. And in this particular slide, you can see some higher concentrations over China and something near New Guinea. Interesting feature. Okay, so why do our users get the Level 2 data that we have? And there are several reasons. The Level 2 data is usually acquired and available at the highest spatial resolution that the instrument can provide. This Level 2 data has not been spatially or temporally averaged. The Level 2 data can be taken and then mapped onto different projections on the Earth's surface according to user preferences. So, because it hasn't been averaged in any different ways or otherwise massaged, the Level 2 data has been subjected to the least post-processing. And one other important aspect is that the Level 2 data frequently includes information about data quality, such as flags indicating weird or unusual conditions, missing data, and these types of things tend to be taken out when a level 3 global data file is produced. And so the next question is, why is a level 2 data subsetter needed? And the level 2 data subsetter is useful for the following reasons. Number one, the data subsetter provides this level 2 data just for a specific region or for several different regions of interest. Now, if you have a level 2 data file consisting of the complete orbital swath, as I showed earlier, you may be interested in data for one region, while that data file has also got data from places several thousand miles away. As you can see in the previous image, the swath goes from nearly the South Pole to the North Pole. Now, AIRS actually orbits where it starts scanning from the South Pole and then goes to the North Pole, which is called an ascending orbit. So we think once you take a subset of the file out, it's easier to look at that subset, that smaller region, than looking at the entire swath, which can be distorted. And the level 2 subsetter also allows subsetting of variables. So it only provides the variables of interest that are in the file, rather than every single variable that you can get. Now, you also have temporal subsetting, so you're only looking at a certain period of time, and you can also do it by dimension. And one particular dimension is that if an instrument uses different wavelengths, such as OMI does, you can also get specific wavelengths. And finally, and this is probably one of the main considerations, the level 2 data files are substantially smaller, and they can be. So the data volume required just to download it, just to get it from us, or to store it on your system is much smaller. Okay, so I assume you've gotten interested, and you'd like to use the level 2 data subsetter. Now, one of the things you'll have to do is you'll have to get what's called an Earth Data Login, which is a username and password. Now, if you don't have one already to do this, you can go to the URL that's listed here, and it's easy to find if you search for Earth Data Login, and you get registered. And you just give them a simple username and password. I believe the username is usually your email address, and then that's all you need. So once you've done that, you'll probably want to look at something. And so in this case, we're going to look at a very big volcanic eruption cloud. And this came from an eruption of a volcano in the Aleutian Island chain called Kasatochi, and it occurred in 2008. Now, if you haven't heard of Kasatochi, don't feel bad, because before it erupted, not many people had heard of it. It's a small little speck of an island, had a little crater and a little lake, as you can see right here in the picture. And here's the lake. And Kasatochi woke up without much warning and immediately looked like it was going to erupt. And the only people that were truly alarmed by this were 2 bird observers that were on the island that realized that they might be in trouble. And so they sent out a distress call. And fortunately, the distress call was picked up by a fishing boat in the vicinity, and it retrieved them off the island, and the island had its first major explosion about 30 minutes after they left. So this eruption was extremely powerful, only lasted about 2 days, but it completely eradicated all the life, all the greenery that was on the island. It actually became an interesting laboratory for how life returns to an island that gets basically denuded like this. Okay, so now I've told you about Kasatochi, and now we want to get the data for the eruption of Kasatochi. So we know that volcanoes release sulfur dioxide, and one of the quantities measured in the atmosphere by OMI is sulfur dioxide in the atmosphere. And so the data we're going to be looking for is OMI SO2 data. So an easy way to find this data is simply to type SO2 in the search box on our homepage. Okay, now when you do that and then click search, you'll get a lot of results. Okay, you can see that 111 data sets were found searching on just SO2. So you can then refine your search. In this case, we're going to look at the source of the data, which we know is OMI, and we'll click on more. And then you get a list of all the different possible sources that you can find, and simply check Aura OMI. And then the search will show you that we only have 12 data sets from OMI that are SO2 data. Okay, so now The first one at the top is the one we want. This is level 2 one-orbit SWAP data from OMI. So now that we've found that, the next thing to do is start the subsetting process. And as you can see, there's a little icon that says subset get data. So to start the subsetting process, you click right there. Now when you do that, this will show you all the data that's available. Okay, and like I said, Aura was launched in 2004, so there's been a lot of days in the mission, and you can see that the full data set is about 180 gigabytes. And that's a lot to download. So we're going to start using these options to refine the various specifications for the subset. The first thing we'll do is refine the date range. Now, I told you that Kasatoki erupted on the 7th and 8th of August, but it took a while for the cloud to get in the atmosphere, and furthermore, it was right next to the date line. And so this actually is a consideration when you're looking for orbital data swaths that may cross the date line. So it turns out that the best 2 days to look for the cloud over the Gulf of Alaska when it started to spread out are August 9th and 10th. Okay, so those are the 2 dates that I've entered. Okay, and the next thing I'm going to do is look for the cloud over the Gulf of Alaska and near the Aleutian Islands. So I drew a search box, and the green box. You could also type in, if you knew the exact coordinates, as you can see in the range, you can type that in as well. And that's what I just said. Okay, so next we want to select the variables. Okay, and so you will scroll down. As you can see, there's several boxes. HDFEO stands for the format. It shows that we want the SWAP data from the product, and we selected the total column amount sulfur dioxide. Okay, and even when you do that, it shows all the data fields that are available, and there's quite a few. Okay, I'm only going to get the ones that are actually the column amount of SO2, and it's in 4 atmospheric layers, which I'll talk about in a moment. And you will then check off. The way to do this is actually to uncheck data fields and then check the 4 boxes as shown here. Okay, so now that we've done that, we've made all the selections that we need to do the subsetting. And so now we'll just click on Get Data, the green button, and then see what happens. Okay, and this is what happens. So we ended up with our different file links, which can all be downloaded individually, or you can use many different packages. And each one of these packages has instructions on how to get the data. We have a document that tells you how to use them to get data remotely and download them directly into your package. But we want to go get them. And we're going to use a package that's called Panoply. It's software that's freely available from NASA. It's from the Goddard Institute of Space Studies. And I'll show you quickly what Panoply looks like if you decide to use it. Okay, and this is what you would see when you go to the Panoply homepage. And I have the URL right there. You can get Panoply for Windows systems, Macintosh systems, and Linux systems. You would download it from here. Now, when Panoply is installed in the system, it's very simple. It creates a small directory, and inside that directory, you will get an icon that looks like this right here. And to start it, you simply click on the directory, on the icon. And Panoply is very simple. It doesn't show you a lot of special screens before you get to the data. It will simply show you a field that shows you and asks you what files do you want to open up. And so you will select your file, which you already have in your system, and then click on it. And so I've taken one of the files right here, and that's what it initially will look like in Panoply. Okay, and now I want to go scroll down and actually open up the various directories until I reach the data fields. Okay, and then to create them, to create a plot, what you do is select one of them, like this. I've selected the first one. And then you just simply click on the Create Plot button that's over on the left, right here. Okay, now, before we view the results and the visualizations, which I'm sure you're all curious to see, I just want to explain what the notations in the file mean. Okay, there's 4 layers that are shown in the file, and the lowest one is the planetary boundary layer. Okay, and so over in this diagram, you can see here's the planetary boundary layer. It's only like 1 or 2 kilometers in the atmosphere. Above that is the lower troposphere, and above that is the middle troposphere, and above that at the top is the lower stratosphere. So those are the 4 layers, and that's what the 3 letters in the file name look like. So here's the results, and initially I'm looking at the cloud in the planetary boundary layer and the lower troposphere. And even here you can see that there is some difference in the structure of the cloud in the planetary boundary layer compared to what it looks like in the tropospheric layer. And this is for August 9th. So this is the first day that you can see the cloud. Kasatoki's somewhere over here, so the cloud has drifted in this direction. Okay, now this is the subsets for the following day. This is what it looked like on August 10th, okay? And you can see that it's already doing some very interesting things. So over here, and this is the planetary boundary layer, the lower layer, you can see that some of the winds have pushed it over in this direction, so the SO2, and also grabbed it and pushed it over to the west. So you can already see that the cloud is starting to spread out. And then up in the stratosphere, you can see that as it's risen, the upper level winds in the stratosphere push a lot more of it over toward Canada. Now, OMI kept looking, and so there's more subsets that you could get from this event. And so this is a couple of different images that show what happened on the next few days. Okay, so you can see, oops, where's my arrow? There it is. You can see a location of Kasatoki. A large amount of it went over the polar regions, but some of it actually went down, drifted over North America, Canada, and even made it over to the Eastern Maritimes over here. And then this image here is another image showing all of these different patterns, and I liked it because August 12th is my birthday. Now, volcanoes are pretty famous for producing sulfur dioxide, but they aren't the only producer of sulfur dioxide. And burning coal for energy can also produce it because coal contains sulfur. So in the winter in China, coal-burning power plants come online. Sometimes they have to turn more on to provide heat and energy to make heat for homes and buildings. Okay, and so the emissions from these plants, combined with the winter weather patterns over China, and can combine and cause some really poor air quality. Okay, and so this is a common occurrence in the winter in China, and on February 25th, 2014, there was one event like this. Okay. And so this shows a couple of images from our MODIS sensor, and you can see in this first one, which may be a little blurry, a couple of locations like Beijing and the Sea of Japan and where the Korean Peninsula. But I'll blow it up a little bit to show you some detail. And so you can see, especially over here in the area around Beijing, and you can see some drifting aerosols. But you can see the air quality was pretty poor, and this is where we're going to look for sulfur dioxide. So I used the subsetter in the same manner as I've shown before, and I made some subsets for this period. Okay, and here you can see them, and I did it. We're looking at the 2 lower layers in the atmosphere, the planetary boundary layer and the lower troposphere, and you can see SO2 around the Bohai Sea right here. And note that the concentration levels were higher in the planetary boundary layer, closer to the surface than higher up. Okay, nice thing about Panoply is you can adjust the map, you can change the color palette, you can adjust the range of the color palette. It gives you a lot of options for displaying data like this. Now, there's one note. Currently, if you went to go use our Level 2 data subsetter, it only creates subsets for the Northern Hemisphere. When we announce the official release of the subsetter, it's going to provide full global subsetting of all of the OMI Level 2 data swaths. Okay, we're currently working on software for the file search engine, and have to revise that so that it can do the capability of doing swaths from north to south. And here are some resources that we have for using the Level 2 subsetter. The first is an online guide that shows you exactly the process that I showed here, how to subset any Level 2 data that's available. Here's the URL for Panoply, so you can download that. We also have a guide on how to view data with Panoply, so you can use that. If you get a large number of files, you can also use a service called wget, and wget allows you to download these data files directly to your system. Okay. And then if you have any questions for us, you can email our help desk, and we will get our experts to answer any questions that you have about it. And I'd also like to repeat that you need an Earth Data login to allow you to download any of the data that you get. Any of the data that's created by the subsets, you would have to be logged in with your Earth Data login. So, it's a fairly simple demonstration. I'd like to just point out that the GES DISC is one of several data archives in the EOS DISC system. They're all generally called Distributed Active Archive Centers, and you can get data from NASA missions and models from any one of these data centers. So that's the end, and we can turn back over to Jennifer, and we'll start out with some polling questions, and then we can do some Q&A. Thank you.
Okay. Okay, great. Thank you, Jim, and thanks, everybody. Just a couple of notes really quickly on one of the slides that, next to the last slides that Jim provided, there were not links to some of those resources, and what I'll try to do at the end is enter those links into the Q&A pod for all of you, or you could feel free to email for those links. So I'll try to get that together, and at this point, why don't we go ahead and move to the final set of polling questions. And generally what we'll do is we'll give these, since we finished a little bit early today, let's give these about 5 minutes or so to give people an opportunity to type in a response for the short answer questions. And I also wanted to mention that during today's Q&A session, we have 2 additional panelists or subject matter experts who will participate in answering questions. The first is Dr. Paul Huva, who is a senior scientific software developer at the Goddard DAC. And the second subject matter expert is Jerome Alfred, who is a support scientist also working at the Goddard DAC. So with that, let's give these questions about 5 minutes or so, and then from there we'll move directly to the Q&A. So thanks, everybody. And yeah, if you have any questions, we'll type those in just a few minutes. All right, thank you. Okay, everybody, we're going to give this about 2 to 3 more minutes, and at that point we will jump into the Q&A. All right, thank you. This is really excellent feedback, everybody. We appreciate the feedback. It certainly does help to determine future webinar topics. So thank you so much for taking the time to provide input here. And we'll give this just 30 seconds or so, and then we'll go ahead and move forward to the Q&A period, okay? Thanks, everybody. Okay, everyone, at this point we are going to move to our Q&A session. And I do have one of the first links here that was referenced on the resource slide. I'm going to copy and paste that into the Q&A pod for all of you. And that is going to be how to subset the level 2 data, the guide for that. It's a bit of a long link, but let me go ahead and get that posted for everyone. Okay, does anybody have any questions? If you have a question, please type those into the Q&A pod, and we'll have our panelists answer your question. Okay, while we're waiting to see if there are any questions, I just wanted to point out that in the lower right-hand corner of your screen, you can see that today's presentation file is available as a PowerPoint for your download, as well as the agenda. And if you highlight any of those two files, you'll be prompted with an opportunity to download the file. And thank you for the feedback on the webinar, Antonio. Okay, our first question is, are the input files for the level 2 subsetter L2 swath or L2G gridded? And if you need me to repeat any of the questions, just let me know. So the first question is, are the input files for the level 2 subsetter L2 swath or L2G gridded?
That, and Paul can probably confirm, but they are level 2 swath. They're not L2G.
The level 2 subsetter will be rolling out with L2G support within a couple months. So they're coming soon, and otherwise swath is already supported.
Okay, thank you, Paul. The next question is how to convert Dobson units to concentration in ppb or ppm. So how can you convert Dobson units to concentration in the ppb or the ppm?
That's a tough one for me. I'm not sure if it's something that can be done directly. Jerome, do you have any more insight on that?
That is doable. A Dobson unit is measuring the total column. So one Dobson unit is equivalent, I don't know exactly, but I think it's equivalent to 1 millimeter STP. What? Yeah, milliatmosphere centimeters. So it is. You need to probably get an a priori of the profile of the atmosphere to do the proper integration, and the online documents, the README documents for the SO2 and the ozone products do outline how to do that with the OMI data.
Okay, thank you so much. And then I'm also thinking for this participant, Yori, we can also follow up offline. I can put you in contact with the speakers and also the Q&A panelists such that you'll have the proper links and know where to find this information. Okay, so thank you for that response. The next question is, what are the measurements of the, I'm not sure if I have this right, what are the measurements of the layer, or the layer measurements? And Giovanni, please correct me if I have not, or clarify if need be. Do I have that right? What are the layer measurements? I'm not sure if that's specific enough. Does that make sense to you?
I'm not sure.
Giovanni,
if he's asking,
could you type in some additional clarification to for that particular question? That would be very helpful.
He may be asking how the actual layers, the width of the layers or the height, minimum, maximum heights are specified, and I'm not sure of that. But
okay.
I did provide I gave you the URL for the Panoply Quick View Data Guide.
Okay, great. Let me go ahead and put this into the Q&A pod for everybody. So the Quick View for Panoply. And then we'll get to our next question. We do have a few. Okay, if you could just, all right, Giovanni, and I'll get back to this in a second here. Okay, so the next question is, in what data format are the output files from the Level 2 subsetter, HDF EOS 5?
So presently, the output options are HDF EOS 5. However, we are working on support and conversion support to several other different output file types. And your feedback in today's webinar will actually help inform which file types will get supported when. But other file type support is coming in addition to HDF EOS 5.
Okay, great. Thank you so much. And then let's see here. I'm looking to see if we have any additional questions. Does anybody have any additional questions? Okay. Walter, you have a question for us? All right, while we are, I will be pasting the next URL, which was the how to download data files from HTTP service with wget in just a moment here. Okay.
I found that, but let me check.
So the question is, let's see, ground truthing the data. Any thoughts?
Are you talking about, if you're talking about validating the OMI data, that it has already gone through a rigorous validation campaign, or several, but if you are talking about having, if you have a ground-based sensor that you want to have co-location, this is, you can use this, draw a little box around your location to have co-located data to your ground-based measurements.
Isn't there a handheld ozone meter you can get?
Yeah, you could get pyranometers or those UV measurements, not, so you probably have to derive it from direct UV measurements, because I don't think you, well, yeah, you could have, yeah, spectrometers will be able to measure ground-based.
I think I'm thinking of a different quantity. Sorry.
Maybe, but in situ measurements is just going to measure where you are. To measure the column, you need to look up, so it's going to have to be derived that way.
Okay, thank you. That's good input. I hope this helps. Walter, if not, certainly we can follow up offline as well. And then there was a very good point that was raised by one of our participants also working with the OMI data. And he mentioned that a lot of the questions that have been asked here can also be found in the data product README files or the data documentation. So that's something to keep in mind as well. All right. Well, let's see if we have any more questions. And okay, I do have the last URL. Give me just one moment here. I'd like to thank all of you for joining us today, and thank you to our additional Q&A panelists and to our speaker, Jim Acker.
Thank you.
All right. Any additional questions from anyone?
I did want to point out I was doing a really quick Google search because there is a thing called microtops. And it was something that I had vaguely remembered, and it is actually supposed to be a handheld atmospheric ozone meter. So you could potentially, I believe it's been done, is you could have a classroom of students making the measurements, and then with the level 2 subsetter, because it provides the highest spatial resolution you can get, you could compare what you're reading on the ground to the ozone that the instrument on the satellite tells you. So that would be an interesting exercise.
Okay, great. Thank you, Jim.
Sure.
All right, everybody. For those of you who are repeat attendees for our webinar series, we may not have a webinar in April, but we do have one scheduled for May. So be looking at the tinyurl.com Earth Data webinar. That's our online webinar catalog for announcements in the weeks to come. And for those of you who may not be familiar, we also have previous data discovery and data access webinars that really cross the earth science disciplines hosted on our YouTube channel, and you'll see that link to the left. I know, no webinar in April. Well, sometimes it's a little difficult because we have to work around our scientist schedule. I'll see if we can pull something off for you, but right now it's looking like no webinar in April. So thanks again to everybody. I hope to see you at an upcoming webinar. And certainly if you have any questions, feel free to email me or the support email address that was listed in the presentation. And with that, with no further questions, we will log off from the audio component, and I'll leave the virtual meeting space open. All right. Thanks, everybody.
Thank you.
Talk to you later. Bye-bye now.